All right, what's going on? I think people will probably be trickling in until 6:05, 6:10, maybe 6:15 the latest. So this is the first time we're hosting this event right here. I'm not expecting it to be super busy, but
Okay.
as we continue hosting it week after week, Wednesdays at 6 p.m., I expect it to continue to grow. So have you had any chance to look over the book that we're going through or reading?
Uh, I couldn't actually go through it. I have to go through it again. Like I didn't do it exactly, but like for the next session, I'll be prepared with the like at least go through the book.
Yeah, yeah. I'm expecting people to go at their own pace anyways. You know, some people are going to read slower than other people. Some people will move through it faster, so there's no real set time limit on it. I expect this just to be this is like the most well-known book in the machine learning area. At least everybody I ask recommends going with this one first, so it's good doorway into the field. There's tons of other books I think are pretty good. But after you read a book like this, I think you could start jumping into more of the scholarly articles and papers and specializing in the specific domain of machine learning that you're really most interested in. This is like a nice overview of just machine learning in general, so it covers a ton of different stuff. But yeah, I'm excited to go through it. We got one other person in here. What's going on?
Um, I'm Nicole, everyone. I have not read the book yet
Okay.
or looked at it much, but I'm um, some work where I collaborate with machine learning engineers, and so looking to kind of learn more about that side of things to help my collaborations.
Awesome. How do you collaborate with them?
Oh, I'm a software engineer, and so sometimes I've interfaced with ML teams before
Mm-hmm.
um, for product development. Yeah.
Nice, nice. Welcome. And then it looks like we have Rob. What's going on, Rob? Looks like you just muted. You were unmuted a second ago.
Okay, can you hear me okay? Sorry.
Yeah, what's going on?
Hey, yeah, thanks for the invite. I'm a product manager, and taking taking two sets of coursework, one machine learning in Python and one is AI at a university. So I'm looking to kind of make a career change. So I saw this meetup and thought it might be useful to network and also just kind of soak up some knowledge.
Awesome, awesome. Welcome. And
Yeah, thank you.
Aditya, we've met before. We've participated in similar events before. How's the you mentioned the open source contribution. How's that going, Aditya?
Yeah, it's going good. Like it's a very like a new project, like a fresh project,
Mm-hmm.
which I think started like 2 weeks ago. So they are still in like the planning stage.
Hmm.
They are just trying to implement kind of dummy components so that they could later on use them to like build the MVP or like integrate them like much flexibly. So
Mm-hmm.
that's what it is. Yeah, I mean it's a good thing. Like I mean it's a start, so there are like fresh issues, some good new implementations. So yeah, I mean it's a good thing for like someone who wants to kind of contribute like for the first time. So it's not like too complex code since it's a start. So you can kind of like build from scratch some models. So it won't be like too complicated for you as well.
Mm-hmm. Mm-hmm. Cool. Nice, nice. That's exciting. Cool. Well, I will go ahead and share my screen. I guess I'll just go through like an overview of the book that we're going to be discussing over the next few weeks. And then as I'm going through the book, you sort of like you encounter different scientific papers. Some of them are from like 10 or 15 years ago, like breakthrough papers in the field. I'm kind of just saving those right now. After I finish the book, do one full read through. I'm gonna go back and revisit those, maybe even schedule specific events to either discuss the paper if other people are interested in discussing the papers, or just communicate the paper in a clear and simple way for people who don't really want to dive that deep into the nitty gritty technical stuff but are still interested in these groundbreaking papers. So we'll see when the time comes on that. Let me go ahead and share my screen. So we actually had a machine learning book club like 6 or 7 months ago, and it was very, very popular. And so this is the relaunch of that. This is going to be, that was more of like just seeing if something like that would work, and it was very, very popular. It grew week after week, and you know, after only a few weeks it was like 10, 15 people showing up every single week. So I expect this to grow week after week, and I just want to let everyone know that showed up today. I appreciate you for showing up and discussing this book with us. So I shared my screen. We're all in the machine learning channel right now. So if you go ahead and double click my name, my screen should pop up. And let me know if you can't see it. Cool. So the book that we chose, and this is like the go-to book as far as everyone I know in the industry is like, start with this book if you want to jump into the world of machine learning. It's Hands-On Machine Learning with Scikit-Learn, Keras, and TensorFlow, 3rd edition. As far as the 3rd edition goes, you're either going to have to buy the book from an online platform like O'Reilly, Amazon, or just Google Books, something of that nature. If you don't want to buy the book, but you still want to go through the material, you could get the 2nd edition for free. Like, I found free versions of the 2nd edition online, but with a field like this, I feel like you really have to get the newest stuff, because if they release a new, I think this version was 2022 and the last one before that was 2017, and just in that short amount of time, there's so many changes in the field that you really don't want to get the newest version. So I chose O'Reilly, 5 stars. And so if you check out the table of contents, I actually already did the fundamentals of machine learning, the machine learning landscape, the end-to-end machine learning project, which was pretty cool. You analyzed the data set about real estate. So it gave you like, it gave you basically a matrix that had a ton of different homes, and each home had many different features like number of bedrooms, location, size of house, that sort of thing. And then based on those features, you were able to predict the price of a home based on that data right there. So it was very interesting. It was step by step. You learn a lot. I had to take the time to actually really slow down and dig a little bit deeper into some of the statistic verbiage. There was a lot of just language I didn't quite understand, being new to machine learning too. So I just really slowed it down and dove deeper into that sort of thing. And then I'm not a Python developer either. Most of my experience is with JavaScript, so I also had to slow down when it came to the Scikit-Learn, the NumPy, you don't really get to Keras or TensorFlow until the second part of the book, so it was mostly just Scikit-Learn and other popular libraries within Python. But this is a really, really good chapter. Machine Learning Landscape, Chapter 1, is just really more theory than anything. It kind of gives you just an overview of the field, different types of machine learning, different ways of solving problems, different ways to approach problems. It gives you a couple examples as far as problems goes. And then chapter 2 is just like all hands on. It's all practical. It's really good, but it's a sort of long chapter. So I just started going through the classification chapter. I'm fresh right here. And this chapter is covering, I'll go ahead and pull up my... So this one is importing 70,000 handwritten digits written by high school students and employees of the U.S. Census Bureau, that organization there. And so they have 70,000 images. Each image has 784 features, so it's 28 by 28 pixels. That's how we're getting the 784. And then based on the pixels of each image, you're supposed to be able to predict what character it is or what letter it is. So far I've only imported the data set. I printed the data set here so you could see this is actually the matrix. This here are the labels, and then the shape of the data set is 70,000 with each one containing 784 features, and then the shape of the labels is you have one label for every character basically. And then if I go ahead and run this code, the last thing I did was I have a function for plotting a digit, so I just take I'm basically passing in, this is the data, I'm passing in the first character with 01. I'm passing that digit into the plot digit function, and then I'm showing it, and so it looks like a 5. That's as far as I am right now, and I'm actually really excited to go through and finish this chapter and understand classification on a deeper level. But I'm learning PyCharm as I go along as well. Did anybody read any of the book yet, or dabble it, read the summary, or even just have any thoughts on machine learning in general, or what brought you here?
Yeah, I mean, the thing with machine learning is like I had taken like a couple of courses in my master's, and also I've done like few projects in my bachelor's. So like, but I'm kind of a software developer, but like the thing with machine learning is the thing which I understood is it's more about like understanding the parameters rather than like understanding the code. Basically, the thing with machine learning is most of the stuff is through libraries. Like they've already have built-in libraries. The only thing which we need to which I felt like we need to understand is all those libraries have like lot of parameters and lot of like options on what exactly your goal is to achieve. For example, in this, the thing with like the digit classification thing, it's more about like you have like 784 like features. Now, the thing with that is I'm not sure, but like it's more about like deep learning, because you are not going to like, you are not manually defining the features. You're basically fetching the features from the image, and then you're going to make your system just train over those data, like the deep learning model or any other model. So the only thing which I understand is like machine learning is more about like setting the right parameters for what you want to achieve. Because if you set the wrong parameters, or like if you set like something really wide, then it would like create really bad results. That's what I kind of have an idea about machine learning.
Okay. Does anyone have any thoughts on that one? Yeah, one of the things two things that really popped out to me as I'm digging more into the world of machine learning, and just a couple insights that seem pretty important to me, just doing a little bit of dabbling so far, is one of them is just, it seems like data has a shape. Like data, depending on the problem you're trying to solve, the data involved in solving that problem, it has a shape. Like sometimes the data is linear, and sometimes it's not linear. Sometimes it's polynomial. Sometimes it's even more complex than that. And it's like, so I'm realizing that it's not about just using deep learning to solve every problem. Like, it's about understanding your data well enough to choose a model that solves that problem effectively. Like, really understanding your data on a level where you're choosing the correct model. Because if you choose a model that's not the best for this data that you're using, then you're not really going to solve the problem as best as you could. So for some problems, you know, I've only dabbled in kind of dove deep into a couple of them. One of them being linear regression with the previous real estate problem, and now it's classification. But it seems like some data is just linear by nature. And so based on data that's linear by nature, you're going to be using a linear regression model. But if you go and you use a different model on that linear regression model, then it's not going to be as accurate, or you're just not going to get the results, or it's just not going to work at all. So that's something I want to dive more into, just like the nature of data and the shape of data and the characteristics and properties of data, and how you choose a model that matches your data to solve the problem in the most effective way. That's one thing that really stood out to me. Yeah. You're a little quiet for me.
Yeah. So I was actually going to say, like, so I think the term which you used, it's more about like the exploratory data analysis. You need to like perform some EDA to understand the factors which you're going to use, like what are those significant factors among those factors, and then kind of apply the model.
Go ahead, Nicole.
Oh, yeah, sorry about that. Is this better?
This is way better, yeah.
Okay, way better. So I kind of like connect with a lot of those things that you were saying, Jim. I think that one thing that gets me is that there seems to be a high level of uncertainty as to what is the shape of the data, and then also there can be a high level of uncertainty as to, well, what model should we use, and then also defining the parameters of that model. So it's kind of, to me, it feels like you're kind of in this like floaty land in terms of choosing things. And yeah, I think knowing more terminology and stuff is important for like my goals and stuff like that.
What do you, a floaty land? What do you mean by that?
I guess I mean, so, if we have these product requirements that are, say we want an input of a video and we want an output of, does this video have a cat or a dog or no animals? Sometimes when I've been like interfacing with ML engineers, there's all these different, sometimes to like clarify, well, what is the success of that? Like, what does the model actually need to be hitting in terms of how many times it's right with the input, or like given an input that it has the correct output? And so, yeah, I think the floatiness is just sort of going from this realm of, here's the input, I know what output I'm going to get, it's deterministic, to sort of, well, what level of error is acceptable, and sort of how to present that to in product.
Okay. Yeah, that makes sense. I saw you unmute there, Rob.
Yeah. Thanks for giving me a chance. So this one, just to kind of clarify, you're looking at the MNIST data set?
Yes.
Yeah. So yeah, I've had some experience with this data set as well as the fashion MNIST, which it's another classification problem where you are given different articles of clothing. And like the floatiness comment, that resonates with me. So just working on a couple of these problems, it's really important to identify what performance measure you're optimizing for when you're training your models. So you can look at accuracy, you can look at precision or recall, and it's really important to understand what each of those means, so you choose the right one. Because what you'll see, especially with classification types of problems, is to validate your results, you'll come up with a confusion matrix, and what you'll come up with for this MNIST data set is out of your test data set, basically, you'll see what of the results that your model has correctly classified, say the number 4, number 1, or number 0, it's correctly identified those as 4, 1, or 0, or it's misclassified it as some other number. So you'll be able to visualize that. And it's really important to kind of go through those steps. Also, someone mentioned earlier, like doing an EDA, also very important, just to understand what's the approach. So for like fashion MNIST, you could use a convolutional neural network. For the MNIST, like deep learning probably will work just fine. But on top of that, you can do Python provides a couple of approaches where you can visually play around with, say, the MNIST dataset. You can adjust some of the data so that when you're training the model is generalizable. So there's some, like when you go through the phases of approaching these problems, you do want to do an EDA, so you understand kind of what the best approach is, what metric performance measure you choose to optimize for, and when you're training the models, for deep learning, you can give it the performance measure that you're optimizing for, and then you can also understand how you possibly need to adjust the images to make your models generalizable and robust.
I saw you unmuted there, Aditya. Did you have something else?
Yeah, so like one thing which like I don't know the name, like the one who just talked before me.
Rob?
Rob, yeah. So like the thing which he mentioned about like understanding like the performing the EDA, the thing which one more thing apart from just performing the EDA is like you also need to understand like, and sometimes this issue which I face, like you also need to understand whether you need to like normalize your data or like scale up your data when you kind of, because like sometimes the values are like when you do the EDA, like if you want to understand the correlation between the parameters or the factors or the features, or like understand how varied they are, because if like one or two features are, they're like 10 features, and like let's say two features are like super varied, it is going to like kind of spoil your model if you involve those two features as well. So sometimes it's good to like normalize the data when you kind of train the model as well. Especially in deep learning, there are some projects where like you need to normalize your data before like training the model as well. So, like to make them all like having like kind of like not equal variance, but like not like getting too deviated from the data. So that's one more thing.
Yeah, so you're saying that there's certain sets within the main data matrix that will skew the entire data. It reminds me of the real estate data set that we were using. There was one community that all the houses were priced over $350,000, and because all the houses in that community were priced above $350,000, there was a couple communities that had set prices. Like there was some sort of price control in their neighborhoods or in their communities where all the houses sold for the same value. Like all the houses in this community sold for $350,000. All of the houses in this community sold for $500,000. And so it was very well controlled. And so these properties skewed the data in certain directions. So we actually had to remove all of the homes that were part of these communities that had set prices from the data set. Otherwise, you would never get an accurate prediction for the other. Is that what you're talking about?
Yeah. So basically,
Uh-huh.
the output basically like there are a lot of you basically I think the term you call it as outliers. If there are like too many outliers, then basically the model like that sweet point of that model kind of shifts.
Mm-hmm.
So yeah, so that's one more thing. Like when you actually do the ADA, you need to transform your data kind of in such a way that it is normalized. There's this term, I don't remember that term, but I think it's basically, if I find that term, it's a very good term they use when you when you, which helps you to first you need to check that your data is basically in that format, and then you do all the machine learning algorithms like regressions and like there are like various. So there's this, I think there's this book, I don't remember the name, but it basically explains you like how exactly you need to do the EDA on a data. I mean, the thing with like deep learning data, like for example images and all, you cannot exactly do that, but uh, like for all those like figures data, like proper data sets, so in that case like you need to kind of like do some it's do some, not just like running the machine learning algorithm, but you need to kind of transform the data in such a way that it kind of gives you much optimized results, like much better model results, like the p value and all. Those are the factors you need to check. Like so like there are like a lot of minor things. Like if you go to deep learning, I think most of the stuff is like it's basically you just tell the machine to do it. But like when it comes to like proper data sets where there are like limited features, I think EDA is very important in that case.
Okay, yeah, because there's certain features that you don't even want to include or that you don't even need to include at the end of the day. That's what it seems like. And the EDA is just understanding your data on an intimate level. What features do we even want to include in this data set, and which ones do we want to exclude from the data set? I remember from the real estate example that there was actually, if you look at all the different features of these properties, most of them were irrelevant. I think there was a statistical lingo, something like the correlation between features or something like that, and it was basically saying like what really determines the price. What are the features that really make a difference and impact the price? And it was only two of the features. There were like 6 or more features overall with each property, but it was only 2 that really held most of the weight as far as being able to predict what the price was going to be. And so at the end of the day, do you really need to include all those other features, or do you just include the 2 features that are the most relevant? And because there was only 2 features that were relevant, I think that's why we ended up using a linear model with that problem.
Yeah, so that's one thing. Like a lot of people, like that's what I've seen. Like a lot of people, like if the data is too, like they feel like the data is too complex and they try to use some complex models, but it's not exactly needed. Like even a linear model would be much better on that data if you like understand the data better and transform it in such a way that linear model is suffices on that data.
Mm-hmm. Mm-hmm. Yeah, so it's really just understanding, analyzing your data effectively, cleaning your data, descriptive statistics, visualizing your data, engineering which features you're going to be using, correlation and relationships, data segmentation, hypothesis generation, and data quality assessment. And I'm sure this is like an iterative process. I mean, that's sort of the vibe I get with this right here, where you're kind of like going through this process multiple times and trial and error until you find the best approach or the best combination of features and that sort of thing.
Yeah, I mean, the thing with like I can give you this experience. Like I was like in my master's, I was working on a project which had like 10 features, and we did a lot of different analysis EDA on that to kind of figure out the significant features. And then we reached at a point where we were like achieving like a good P value and a F value, like a good hypothesis, like kind of matching. And then like we kind of removed those couple of features which were like deviating a lot, we felt. And then there was a point where the model went much bad. So like it's kind of an iterative process you need to keep on doing till like it won't be just done in one go. You have to keep on doing. You have to like find out like whether the like it there would be a point where the features might like if as you keep on removing, the model might get much bad. So you need to again bring up few features and check the correlation between those features, because if you remove like one, if there are like two features which are like highly correlated, they might affect the model because they are affecting each other. So that also spoils the model. So there are like lot of stuff you need to understand, like when you perform the EDA.
Mm-hmm.
Just to add, this is Rob. Just to add to the last comment, some of the approaches provide ways to tune the model. Like if you're doing a classification style problem, like with MNIST, you can tune the hyperparameters. There's ways to do that. So some of it, there's a little bit of an art, like when you're putting the different, whether you're doing how you're assembling your dense model, dense layers versus dropout, if you're doing back propagation in your neural network, so you have that, but there's some approaches that will allow you to tune the model, and however many epochs you want to run, that's also a little bit of an art versus science. So again, there's a little bit of like floatiness to it. And then, but if you're doing like a regression or forecasting type problem, you do have lasso and ridge. So what that does is it looks at the like covariance between some of the coefficients or drivers of the forecast, and allows you to shrink those down. So some of them will actually shrink down to 0 or they'll go away. So just don't sleep on lasso and ridge if you're doing some sort of regression style problem.
Lasso and ridge. Lasso and ridge regression.
Yeah, those regularize the model basically, right?
Yeah, exactly. They regularize the model. You'll shrink some of the coefficients down.
Okay. Is this similar to the functions that you're using to minimize errors too?
Similar, yes. Yeah.
Similar conceptually.
Yeah.
Okay. All right, that makes sense then. Yeah, because there was two that I encountered in the first chapter. One was like the mean root squared error, and one was the mean absolute error.
Yeah.
Yeah.
RMSC. Yeah. So yeah, I don't want to minimize the importance of EDA. You definitely want to run EDA to look at how, again, if you're running some sort of regression style approach, you have to look at how correlated some of the variables are. Some you can get rid of up front, and you need to be really clear on what data is missing if you have null values in your data set. And some approaches are really sensitive to that. And as I think you mentioned earlier, Jim, you mentioned earlier, like in the real estate data set, if some values are kind of capped, or if you have some values that are larger than others, what they'll do is that coefficient will get too much importance in the model. So you have to you have to standardize like z-score, normalize. You have to normalize your values in the data set.
Mm-hmm. Yeah.
So, but you have some, you need to do the upfront work in EDA, but you do have, you can help yourself with some regularization. You have lasso and ridge for a regression style approach, and then for deep learning, you can tune hyperparameters. And there's actually there's you'll see there's for a couple of, not just deep learning, you have some there's random CV. Let me see. There's a couple. There's two approaches that I know of where you will cross-validate the model, and that cross-validation can test with various hyperparameter values, and will give you the best case, or the optimized case for your model.
Mm-hmm, mm-hmm. So the lasso, ridge, tuning the hyperparameters, this is more tactical actions you could take to improve the results of your predictions or the results of your model, whereas the EDA is something you want to do with every data set, regardless of the model that you're using.
100%. Yeah, you said it well.
Okay. That all makes sense.
I'm just putting like this thing, like, I mean, if anyone, there's this tool called as JMP. So this, I just put it on chat. So this tool basically, it's like, if there are like people who don't want to like focus too much on writing the code from scratch for the EDA and like understanding it, and just like focus on machine learning more and get some other results for the EDA, this tool basically, you don't need to write any code. You just need to import your data, and it will give you all different features which you can run on this data set to understand the EDA.
Mm-hmm.
Like,
so this automatically analyzes your data for you?
yeah, you just need, it's like just clicking the options, choosing the right option. Like, let's say if you want to perform like a correlation, there'll be an option of correlation. It will give you the correlation. Like, you don't need to like write a code or something. If you want to normalize the data, I think there are some options to normalize the data as well. Or like if you want to see box plots to understand the variance, if you want to run like some ANOVA table, all those are like some kind of operations, like analysis operations which you can perform on the data set. You don't need to exactly write the code like you do it in Python using a library or something. This is basically like a Dropbox. So it just give you an option, click on it, and it will do that operation, and it'll give you the output there itself.
Mm-hmm. Mm-hmm. Okay, nice. That's cool. Yeah, there's still a lot of lingo I need to pick up as well. You could tell because as Rob is talking and Aditya and even Nicole is chatting a little bit, there are words that you guys say where I'm like, I've heard it, but I don't quite understand the depth of it or exactly what it means yet. So I'm excited to learn more.
Yeah, oh my gosh, just hearing all this terminology is really great. But also like so many things that I'm not familiar with on my side of things. So this is good.
Awesome. I saw that you posted in the chat, Aditya, so we're going to implement the modules hands-on while going through the chapters. There was actually someone who suggested that they wanted to, Justin, another member, he actually attends our in-person meetup on Sundays, and he actually went to school for specifically machine learning, and he wanted to go through the chapters step by step as a group and build the models and then discuss it as we went through it. I don't know how effective that would be. I feel like that would be moving super slow. I'm definitely down for something like that, but I also want to do it on my own time as well, just because I like to go down rabbit holes that I don't know if everyone else likes to go down.
I mean, I'd say there's no point. Like, when it comes to machine learning, like, I feel like if you do something in a hurry, like, we are going to miss a lot of stuff. I think if we are like for me, like, it's kind of like getting into this field. like I haven't done too lot of stuff in machine learning and EDA. I just know the terms and understand it. But like if I'm doing it hands-on, I would like to like go understand with a very good pace rather than just like leaving some stuff. And because there's no deadline we need to reach. It's basically just getting a complete exposure to this field and understanding in depth all the concepts, so that in case if like that would really help us later if we know well the concepts. Because a lot of people, like I don't know, this is something which I've heard a lot. They say that like a lot of people like who say claim to be like machine learning engineers, they basically like just use libraries. They don't, a lot of people don't know the lot of concepts inside it. They just try to use the library, like see some online GitHub repo, run the model, and they got the model and they say okay, it's done. So I don't want that to happen.
So you don't think that we'd be moving too slow if we just said, all right, hey, we're starting with the end-to-end machine learning project. We're going to go through, we're literally going to read this chapter together, even maybe take turns reading it, like, hey, everybody reads like a section each, and then we discuss the section while someone's reading. Other people could be, you know, like you come across a word like I don't know, we come across something like there's definitely things that
Yeah, I mean, the thing is like when I went through my master's course, I know the professor, the speed he went in while explaining the concepts, and that just went a bouncer to me. So in stats or like in machine learning, there are a lot of concepts which like if you go in a very fast pace, I mean, I feel like I might miss some stuff.
Yeah.
So I mean, I would recommend to go it in a really good pace. I mean, that's like my opinion.
Yeah. So are you saying though, like read the book together at a slow pace and discuss the paragraphs and the book as we read it together? Or are you saying should we have like reading assignments where everybody reads something and then we could come and we could just discuss what we've read together? What do you think as far as it goes? Because the sky's the limit. This is week 1. Right? So we could do whatever we want as long as it's providing the most value for everybody here. That's the most important thing to me. And I agree with you on moving too fast with anything. I think the world of programming, if you really want to absorb concepts, is you just really need to slow it down. Even with data structures and algorithms or learning new frameworks or languages, like I want to read the documentation. I want to walk through functions line by line, step by step, watching how the variables change at each step to understand what's actually happening here. So I agree with you. I think moving slow is the way to go. That's the only way that you actually understand things. So I don't know. What do you guys think? I read documentation, dude. I sit at the command line and just explore the -- help or the config. Like, I just want to understand things on a deep level. So that's me. Not everyone's like that though, you know. Everyone learns different.
I'm fine with like going like with like 1-to-1 pace. Like I mean, I don't have anything in a hurry. Like I don't want to like pass an interview for machine learning in the next 2 weeks.
Yeah.
So
Yeah,
I can go with like this small pace, like because anyways it's going to be like a once a week. So like I mean, I'm fine with like understanding it and like using that 1 week to later on whatever we read to later on understand it in on my pace, and then in the next call we can go ahead with the next chapter because that 1 week we used to understand it. So
Right.
yeah, I'm good with any opinion, like, but
What are you thinking, Rob? What do you think might be the best way to explore this topic?
Jim, I'm more like you. I have to. So I mean, just speaking from some experience, and I haven't done this a whole lot professionally. I've just done it in coursework. I've done it a little bit professionally, but I need to look at the documentation and look at a couple of the look at the parameters, potential values for those parameters, try different things out. Because I mean, I can give you innumerable examples where I got into a habit of using a function a certain way without using certain parameters, and I missed out on a lot. So I think it's good to have like an iterative approach, but also if we want to go kind of gradual, that's fine. That's kind of how I learn. That's how I best learn, is like by reading the documentation, going back and trying different things, testing my understanding. And if I don't have a great understanding, like kind of cracking it open and doing like debugging and seeing how things are transformed by the model. Yeah, so that's I agree. Like the kind of what you're describing, Jim, makes sense to me.
Cool. Nicole, what are you thinking?
I'm pretty open. I think the slower the better, kind of that no rush mentality. Um, I like to go over material first on, like, read through something, kind of like the idea of having a assignment of like go over this many pages or something, and then come together as a group and then like go over it again on my own afterwards. But to be doing like some of the hands-on project stuff together, that would be really cool.
Okay. Okay. So, I mean, I'm still gonna. I think repetition is key. So I'm still gonna go through the book on my own. They have. So if you actually go to the book, if you go to, I think it's like the preface. It talks about a couple of the frameworks being used, and then all the code examples in this book are open source and available online at this GitHub. But then it also says there's a Google collab. Actually, where is that? Okay, so they have the code here. There is a Google collab and a Jupyter notebook that allows you to walk through the code examples. I believe it's in this section here. So that's a nice opportunity for us to just walk through the code line by line, discuss those, and go through the concepts. I still personally, I like just typing out the code myself, and even like typing some notes, typing some comments, just to make sure that I understand all the lines of code. And even like I start with just simple comments like this, but eventually I start jotting tons of notes, which a Jupyter notebook seems like it would be much better for something like that. But on my laptop, I have the real estate problem, so there's much more notes on that one there. All right. So we have the fundamentals of machine learning. That's part 1 of the book. And then part 2 of the book is neural networks and deep learning. So in part 1, it's going to talk about the landscape. This landscape chapter right here, this is more of like, what is machine learning, why use it, types of machine learning, main challenges, testing and validating. Like some of the stuff we're talking about now, hyperparameter tuning and model selection. Which this is all good stuff too. But I think this first chapter, it's short enough where you can see, like, it's really not that long. It has images too. And I think this is a good one for, I think I'll tell people like, hey, if you're attending this book club, just read chapter 1. Like that's kind of what we expect. It's just so you know enough about, this is covering stuff like why using it. It uses the spam example, spams in email, like a spam filter for email as an example. So you get to understand machine learning with a real life example. It gives you an example of different applications so you understand where machine learning is being used, different learning systems, so training supervision, supervised learning with the spam example, unsupervised learning, clustering, I think more clustering, anomalies, semi-supervised learning, self-supervised learning, reinforcement learning, and then batch versus online learning, instance-based versus model-based learning. I think this is a good chapter where, like, if you're going to attend this meeting, just read this chapter. It gives you enough knowledge to at least have a conversation, like have a starter conversation, so you're not coming in here like, I don't know anything, you know? And then I would totally be down to just start from the end-to-end machine learning project if everyone's down with that as well, and just work through building this. I know the first thing we're doing is we're importing real-life real estate data for the state of California. Like you said, we're doing the EDA, we're framing the problem, we're understanding the data. I think, Nicole, you mentioned framing the problem in the way beginning of the meeting, going over some of the error formulas. And then there's lots of statistical language in here too that I went down rabbit holes on just to understand a little bit better. But after going down those rabbit holes a little bit, oh, here we go. All the code examples are available open source and available online. Jupyter Notebooks. So working with real data.
Also, I have a suggestion. Like, when we kind of like understand a particular concept in detail, like let's say if we do like a certain concept through going through all the Google Colab, or like let's say a really big concept, then what we could do is like we could think of like using Kaggle to like pick up any data set and try to do kind of similar operations, and like because Kaggle has like lot of data set, so we can pick like one data set together and then use that data set to like together kind of play around and like understand it.
I have an idea. How about as we go through the chapters, actually, I mean, the end-to-end machine learning project, that's a nice start, but it's just, you still go over a couple different types of training. It's a nice starter, but I say we do something like this. Like we do the classification chapter, we do this together, and then after the classification chapter, we create our own model. Like we solve our own problem with classification that's just a unique one to really reinforce everything we learn with the classification. I mean, if we're really slowing it down and taking our time to learn this stuff, sure, we could go through, and reading a book and following these examples that they have in the book is basically like taking a tutorial with a different format. You're not watching a video like the typical tutorial, but you're reading a book and you're still taking a tutorial at the end of the day. If you really want to reinforce and learn all this stuff, you have to build your own projects. And so like you said, we should take everything we learned from each chapter, starting with the classification chapter, and then we create our own classification model with a data set that, you know, we vote on or we choose, you know?
Yeah, right. Yeah.
I'd be down for something like that.
Yeah.
I guess the real question is, do you want to start with the end-to-end machine learning project, or do you want to start with classification? And do you guys have access to the book, or will you be able to access the book?
It's paid, right?
It is if you get it from O'Reilly.
I do like I didn't find any online thing about this book. Like the only website it takes is like to the O'Reilly.
Mm-hmm. Yeah, they have. You could order the book from like Google Books or Amazon. Just get the hard copy, but I wouldn't recommend the hard copy ever, really, just because of how quickly things change. Okay.
Yeah, I don't have the book, but I can get the book online. Yeah.
Okay. Yeah, I expect this meeting to grow week over week anyway. So I would say that we start with the end-to-end machine learning project. You know, I've already done it, but if Aditya and Nicole, you haven't done it yet, I think it would be really cool to just really slow down. I'm willing to go back to that chapter, go through it, because there is stuff that I explored independently that I would have liked to explore and discuss with other people that I think it would have reinforced. Yeah.
Yeah, so yeah, I mean like I would like to like actually like do that. Like I'm fine with going ahead with like doing that end-to-end machine learning thing.
Mm-hmm. Okay. Cool. We could go ahead and I guess we could start it now. If you're both up for it.
How long are you going to expect the meetings to be? Like in a day? Like what's the time frame?
So I have it scheduled from 6 to 8, but I was thinking about how long. I was going to change it to 7:30 because I do have an event from 8 to 9, Beginner's Guide to Data Structure Algorithm training for the junior level membership. So I'm thinking about shortening it a little bit just so I can have a little buffer in between events. What are you thinking is good for something like this? What do you think?
Yeah, I mean today since like it was kind of like an intro thing, so it took some time. But I think 1.5 hour, like if we like start on time and like properly begin it, like exactly on time, I think 1.5 hours should be enough, like for, I mean, because today like it was kind of like most of the time went in understanding what we want to do, right?
Mm-hmm.
So, but like I think 1.5 hours should be good, like to like just utilize that 1.5 hour time to actually just work on it. So I think that should be good.
Mm-hmm. Mm-hmm. Okay. Yeah, that sounds good. And so what I'll do then is we'll plan for next Wednesday when we meet back here. We'll start with chapter 2, the end-to-end machine learning project. I'll have my the thing is I'm using PyCharm, but I think it would be cool if because with Visual Studio Code, like when I'm doing like web development trainings or data structure algorithm trainings and that sort of thing, I use live share in my Visual Studio Code. And so I'm able to invite people to my code editor and it's more interactive and other people could code along with me. So I would really like to do that with this. I just don't know if there's a live share extension for PyCharm. I would have to look in.
I mean, I was saying like instead like because the thing with this is like it's less about debug and like it's better since everyone is like doing for the first time, like at least me, and like so it's better like if we can like do it like in on our notebook. Like I usually use Google Colab for such kind of things.
Mm-hmm.
So like I would like to actually like do it like personally just for me from fresh by while actually everyone else is doing. So that's what I would like to do. Like
So you have your own copy.
yeah, I mean like because it's kind of like you don't have like too much of code like you have in like your web applications and all, right?
True.
It's
True.
about like yeah, so I think it shouldn't take much time like if everyone would try to do it at the same time in their own notebook. But yeah, that's my suggestion.
Mm-hmm. Okay. Yeah, that sounds good. That makes a lot of sense too. If I was attending a meeting and someone else was hosting it, I would definitely be doing the code on my own. And I would want my own copy, and I would actually want to type everything out myself so I could really really learn it. Yeah, so all right, what I'll do is I'll go ahead, I'll go back to the meetup event. I'll modify it a little bit. I'll let people know, hey, this is the book we're reading. This is the book ID. Before you attend this event, read chapter 1, just the landscape of machine learning. That's the bare minimum. Just understand the basics, the bird's eye view overview of machine learning. That'll give you enough knowledge for you to actually have conversations about it and understand a little bit about what we're talking about. And then I'll let people know that we are working through the chapters one by one. We're currently working through the end-to-end machine learning project as a team, literally reading the book together, digging into words we don't understand together, just really keeping a slow and steady pace to make sure everybody's absorbing all the topics, all the lingo, all the concepts, and then I will change the time from 6 to 7:30 instead of 6 to 8, a solid 90 minutes for the event. That sounds pretty good. Anything else either of you think I should keep in mind, or any other changes or additions you think that we could make to make this either more accepting or just better for everybody who's attending?
Yeah, no suggestions as of now, but like as we go ahead, I feel like we'll understand it much better exactly how the session is going on, like when we'll actually start doing it.
Mm-hmm. Agreed.
Yeah, I agree with that too.
Cool. Awesome. I'm going to I guess we have the chat here so we could keep the chat conversation going, because I'm gonna definitely start with the end-to-end project with you guys, with the group here, but I'm still gonna continue working through the book independently and starting with this classification problem. So as I work through this classification problem, if either of you are also working through the book, or if you come across any machine learning knowledge that you found valuable or insightful, or you learned something, please share, because I'm totally open to learning from you guys even throughout the week if it's not a Wednesday during this event. So just share it in this chat channel right here, and I'm going to share any insightful or valuable stuff I think is worth sharing here too.
Yeah, sure.
Sounds good.
Awesome. All right, cool. Then I will look forward to next week, and we'll go from there.
Yep.
Have a great week.
Have a great
Yeah,
week, guys.
have a great week.